Hello friends and welcome back to my channel. I would like to address a very important question which is being continuously asked by many viewers. And this question is whether Newton's laws are incorrect. So let us try to discuss this in detail with the help of a simple diagram. Any theory or a scientific model predicts certain events in the universe. So a theory or a model, scientific model X would predict an event A in the universe. And similarly, it will predict event B in the universe. And so it will predict many such events in the universe. There are so many of them. And if the events predicted, say event B, event A, event B, and so many such events predicted are consistent in nature and they are accurate in nature, under all circumstances, under all situations, then we assume this theory or a scientific model X to be correct. However, it may happen that there is another event Y, yes, event Y, which also exists, and we expect that this theory or a scientific model to predict event Y. But this scientific model or theory is not able to predict Y consistently and accurately. So we have two situations where this theory or the model is able to predict event A, event B, and so many event C and so many such events very accurately, consistently, but it is also not able to explain certain events such as event Y consistently and accurately. So what does that mean? Does it mean that this model is incorrect or is it something else? What happens is, and what is assumed is, that if such type of scenario exists, then the assumption is that this theory is probably not sufficient in nature, not absolute in nature, not holistic in nature. And if that is the assumption, then probably this theory has hit its boundary condition. So we depict this theory or model X with a certain boundary. And all events within the boundary is accurately predicted by this theory, whereas events lying outside this boundary is not predicted consistently by this theory. So now we come back to Newton's laws and look at Newton's law of gravity, for instance. So if theory X is Newton's law of gravitation, then Newton's law of gravitation would predict an event A, and say this event A is say the orbits of planets, which it does very well. Event B could be, we can say this is tidal forces or gravitational effects creating tides that we all observe in our daily life. And so it can make many more predictions, right? But there is an event Y. This event Y, Newton's law of gravitation is not able to predict. And what is that event Y? So event Y is precession of planets. We call it precession. Precession of planets is not explained by Newton's law. And this is my event Y. It is lying outside the boundary. And precession of planet actually means that the planets have an orbital plane, and this orbital plane starts shifting. So what happens in precession is, this is our sun, and this is the orbit of a particular planet. And then as it orbits, the plane of the orbit starts shifting like this. So it starts shifting. But this is not predicted by Newton's law of gravity. So we see that Newton's law of gravity could predict so many events, but is not able to predict this particular event and many such events like this. So we say that Newton's laws are not sufficient, they are not absolute, they are not holistic in nature, and they hit a certain boundary condition. Einstein realized this, and therefore he said that we need a more holistic theory which explains all the events happening in the universe and not only a certain set of events. So if we look at in a broad way, I will not get into details, but broadly on a conceptual basis, if we look at the Newton's law of gravitation, Newton's law of gravitation is a very simple and common equation which we all must have gone through in our schools. That force of gravity is gravitational constant, big mass, small mass upon distance square or r square. Right? I can write this formula as gravitational constant, big mass, small mass upon space square, because r is distance and distance we can write as space square. So what is missing in this formula? If you see, this formula has the dimension of space, but there is no dimension of time in this, as Newton considered time to be absolute. And that is the reason why Newton's theories are all not very sufficient in a certain situation, because it does not consider the aspect or the dimension of time in its theories. It considers time to be absolute. So if you look at situations of intense gravity and very high speeds, relativistic speeds we are talking about, then these Newton's laws do not hold over there in such scenarios. So which means what I want to say is that beyond this boundary, any event which happens, you see this boundary, this is beyond which these boundaries, if I look at intense gravity, a zone of intense gravity and high speeds, this is the zone which will not be explained consistently and accurately by Newton's laws, and we need something else. Einstein realized this, and therefore he embarked on his journey to find out a new theory, a theory which would explain all the events in the universe, all these events and these events. And therefore he came up with his theory of relativity. Yeah, so he came up with his theory of relativity. So this is a larger domain. This is Einstein's relativity. Which includes all, explains everything, and is more holistic in nature. Where these zones that we talked about, this is the zone, the boundary, you see red boundary, this zone is known as zones of validity. So this is Newton's zone of validity. And this entire thing is known as Einstein's zone of validity. This is Einstein's zone of validity, the entire thing. Now the question comes whether Einstein's relativity is absolute in nature, because this was assumed that when Einstein came up with theory, this is a more holistic and absolute in nature theory which is there. So the question is, it is not. So where does Einstein's theory of relativity have a boundary condition? If it's not holistic or absolute in nature, then where is the boundary condition? The boundary condition of this theory is inside the black holes, because in black holes his theory does not hold. So if I look at beyond Einstein's boundary, I would write here as black holes. This is the zone where we don't have answers from Newton's laws or Einstein's relativity. And so when scientists realized this, they said that we need to come up with even more holistic theory. We should explain everything, a theory of everything. And this theory of everything, which scientists are currently working on, and they are putting all their efforts into this, is known as the theory of quantum gravity. This is the theory of quantum gravity, which is a mix of quantum science and relativity. It's a combination of both. They are looking from both perspectives. And it is believed that quantum gravity would be the answer to every event in the universe. We must try to understand, friends, if you look at relativity or if you look at quantum science, even Newton's laws to that extent, they will all explain the phenomena. They are basically models, and they will all explain the phenomena of how the event is happening. But many of these cases, the answers have not been found out as to why the event is happening. And this is across all. This is across relativity and quantum science. The answer to the question why, in many cases, is being looked at. We have still not got those answers. But we have beautiful mathematical models which will tell you how the event happens. So how space-time bends, you will have through Einstein's equations. But why it bends, we are still looking for answer. Same things in quantum mechanics. You have a lot of modeling and models over there which tell you how the events happen. But why the events happen is still being looked at. So, I hope I have been able to address this question. Newton's laws are not incorrect, but yes, they are not sufficient. They are not holistic, and they are not absolute. And the idea in science is that every time you come across an event Y, which normally is referred to as scientific anomaly, we need to seek answers in greater depth, and we need to look at theories which address not only these anomalies, but also explain these events at the same time. Very good example is people who have watched Interstellar, and I would suggest people to watch that movie. It's a beautiful scientific movie, right? You you watch that movie. Every scene of it is trying to address or trying to look at gravitational anomalies. You look at Dr. Brand or Cooper or Murph, the daughter of Cooper. They're talking about gravitational anomalies, and they're trying to come up with a scientific ways or to address the same. They don't have answers to those gravitational anomalies. Similarly, when Einstein was there was this anomaly of event 5 of precession of planets, right? Was discovered, and so this was an anomaly, and Einstein wanted to address that, and that's how he came up with the entire theory of relativity. So hope I have been able to address this question. Friends, if you have any other queries, you can ask me. You can put your questions in the comment box.